So hi, I'm Leif. I've got very many hats to carry since, I solve all the problems I hear. Right now, I have the framework philosopher hat on me. So there's two framework features that we have been working on that I think are really, really exciting, but I also think they need a little bit of extra explanation because there's a whole bunch of background behind them. The first one is very much about blocking, but first a little bit of background. So what do we as Vaadin do really? I think it boils down to we help build rich web UIs and for the Java backend. If you look at well, what are your options? If we talk about the Java backend, then it's well, we got Spring, we got CDI Jakarta EE Quarkus. All of those out of the box, they give you an MVC framework. You can serve HTML or JSON or something as response to a request, and that's all you get. That's not a rich UI. You need to do all the HTML and so on your own. Then on the other end of the spectrum, if you really want a rich UI, you go to, well, React, Angular, Vue, single-page application frameworks. They have the opposite problem. They say, we don't care about no servers. You do whatever you want. And that's also not good because you really want to have those together. Why do you want to have those together? Because this guy, no, actually not that guy, he just formulated it. Conway's law. Basically, well, there's many formulations of it. I like this one because it's short and fits on a slide. The structure of any system designed by an organization is isomorphic. That's a weird word. Isomorphic to the structure of the organization. So what that means is your code will look like your organization. I think Richard Stallman put it really nicely. He said, if you got 4 teams working on a compiler, you will end up with a 4-pass compiler. It's really that easy. If you try to make a 3-pass compiler with 4 teams, you're screwed. If you try to do a 5-pass compiler with 4 teams, you're equally screwed. That's the way it just goes. So when we got these team structures and the application structures and how go they hand in hand? It's very, very easy when you start out. It's really simple. Really simple architecture. We got the presentation layer, we got the application layer, so business logic, and the data layer, like we learned 20 years ago. And when you start out, it's only you working on the application. Of course, you do all of those things because nobody else is there to do it. And you're a full-stack developer. Congratulations. And you're a full-stack team because it's only you. It's really simple in that way. And then the application it's a huge success. Keep adding more developers to it to make it go even faster. And gradually, it's too many people for one team. And this is where you get to Conway's law. What do? You need to have 2 teams. How do you structure an application for 2 teams? Well, you have 2 different business domains. In this web shop example, we got the orders application and you got the payments application. And each of them is a separate team, a separate application. Because the other way around, that would be terrible, wouldn't it? You would have like this. You got a front-end application by a front-end team and a back-end application by a back-end team. And then whenever you want to add anything to that application, nothing happens. Well, the front-end team does something. They need something from the back-end application. They file a ticket. They wait. They are blocked. So this is like those old-fashioned hardware threads that Josh was talking about. You don't want to do that. You want to have virtual threads. The teams don't need to be blocked. They can just work end-to-end the whole feature that they're adding. Maybe, eventually you need maybe some specialization. Some persons in that team might be better at front-end things, more experienced in that. Others might be experts in business logic or in the database stuff. But anyways, it's one team. They work together as a virtual thread. They're not blocked, and that's the awesome way of doing things. The question, though, is, because we got 3 layers here. We got the presentation, we got the application layer, we got the data layer. But traditionally, for some reason, why does the application layer and data layer go into the same application? You don't have kind of a business logic application and a database application. Well, you got a database application also, but still you got kind of the database accessing code in the business application. That's not a separate application. And I think that's very much about tooling, because, well, if you're going to use these React, Angular, Vue, they are complex technologies. You want to specialize on that, and it might be kind of, people might feel that it's more than I can comprehend just that small part. And that's when you specialize, that's when you end up with separate teams, that's when you get blocked. But the trick really is tooling, because what really happens with the application and data layer being in one single application is that you got this awesome tooling. You can call it JPA, you can call it Juice, you can even call it JDBC. Well, don't do JDBC. But the point is, we got this tooling for Java development that really wants to live together with your application code, with your business logic. And that kind of, it leads you, it kind of forces you to just do everything in one application. And I think Vaadin is exactly the same for the front end. With our approach, and this is, I would say, our secret sauce, our magic superpower, like Josh was already quoted, it's what gives you, what was it, high on power. Because when you, with the help of Vaadin's tooling, or I mean there's other ways, but ours best, with our tooling, it's easy enough to have everything in one application. It's easy enough to have all developers working on the same thing. Or, well, I mean the whole team working on that slice of the business, not having front-end, back-end developers. So that's the first piece. We're getting to the framework feature eventually. The second piece is a little bit more of strategy. What are the things that Vaadin can control? What are the things we can't control? Because we can't control your team structure. We can't say that, oh, now you discovered Vaadin, now you're really happy about this, and by the way, you need to reorganize everything in your engineering team. That's not going to fly. We can't say that, oh, well, to start using Vaadin, you have to throw away all your existing code. Good luck. No, we need to fit in. And what's the thing we need to fit into? Well, we're in the front-end space, and I found this state of front-end survey by someone, I don't care who it was. They got 6,000 something respondents to that thing, so it's kind of decent. And there was a little bit uncertainty data there, but at least 70% of front-end developers in this survey, they are in a full-stack team. They said that they have either a full-stack developer or a back-end developer in the same team as they were as a front-end developer. And also, the other thing is 86% of those, they use React. I have spoken with some of you, and you seem to not really like React. I spoke with one guy who said that they started building, they had a Swing application, started, well, let's make this modern with web UIs and so on. Let's add a whole bunch of React developers to work on it, and it just didn't work. Things were so slow, exactly because of this blocking. But I would say that's not React's fault. That's the React ecosystem's fault. React itself is awesome technology. Instead, what we thought up, Jonas already showed this, we got Hilla is one Vaadin framework and Flow is the other one. It's the same philosophy, the same UI components, the same Spring Boot or any other Java backend at the bottom of the layer. But then in between, you can choose, if you got those React developers, if you got this existing React code, you go with Hilla. And then you can still make that one single full stack application with a Java backend. Or if you don't have that, if you want to go really full speed, get everything out of your Java knowledge, everything out of the JVM, then we got the Flow option. And both are really great. But there's always a but. When you're using Flow, you're building a Flow view, you're using Flow components, it's rendered inside a Flow kind of application-wide layout. When you're using Hilla, you use React components, and you use them inside a Hilla layout. And the problem here is that, what if you want to mix and match? So actually, originally, we had this one extra thing, lower left corner. Well, you can take a flow view, built with flow components. You can add it inside a Hilla layout. And in that way, you can mix and match. So you can start with, I got this Hilla application, I got this React application, it didn't use Vaadin. I realized, oh, I want to do full stack, I want to do Vaadin. You add Hilla to it, make those into Hilla views, and then you can also start adding flow views to it. But what if you want to go the other way around? Well, luckily, Jonas was talking about how we were kind of broadening the platform, but we have also now made it more seamless. So now we got just one big checkbox. You can mix things in whatever way you want, if you want, because not always is that the way to do things. But if there is, and actually later today we're going to look at when's that, how do you do it, when shouldn't you do it, because that's maybe just as important. So stay tuned for that. So that was the blocking part. Then there's one more thing on my mind, and this is maybe even more exciting, but it also goes even further. In the front-end space, if you're using React, Angular, Vue, all of those, in the past couple of years, there's this thing called signals that has really caught on. That's not the kind of Batman signal that Jonas is lightning when there's problems for me to solve, but this is about detaching rendering from UI state management. This sounds really abstract, and it kind of is. So let's make it really tangible. This is a React component. It's a quite simple React component. Don't even be scared of the syntax. I can explain it. So this is a count button. It's like you have in every single business application anywhere. It's a button, and when you click it, it tells how many times it's been clicked. You can maybe imagine it as, well, notifications or something, how many notifications there are, how many 100 messages. It doesn't really matter, but this is just 5 lines of code, so it's the simplest I could do. This button receives from the outside a count. It's a count signal. And the magic here is that this button, it doesn't need to know anything about what does this mean. It only knows when the button is clicked, I should add 1 to the count in that signal, because the signal is a holder of value, of UI state. And then the other thing it does is that it renders text labels, so that's the content in this button element, is the click count and then the signal value. And the magic is that whenever that signal changes from anywhere, this component will automatically update the number what's shown there. So not only if it's kind of part of this view, it's only this click button and nobody else uses that count number, then it of course works. But you can also have 50 of those buttons in your same view. That's really, well, it's not maybe good UI design, but it's something. And anytime you click any of those, they all update, because it's just shared UI state. But it gets even better than that, because what if you could share this UI state between multiple users? So whenever one user clicks the button, all the users would get their number updated. And there's really kind of endless possibilities here, and that's what makes it so exciting. And the point really is that this all is possible because the UI state is detached from the rendering. They are completely separate things. We can take this one step further. This is the same in Flow. This doesn't work today, but I hope it will work in the future. So we could make a count button. It's a Java class extending the built-in button class from Vaadin. We receive the same kind of signal with the count from outside. We don't have to care about what's behind this signal. All we know, it's a number, we can increment it. We use the not yet existing Java string template syntax to actually say that, well, this is a click count, and then it also got this hold that should always contain the value from the signal. And then in the click listener, when we get a click event, we just increment that, or tell the signal to increment the value. And in this way, we can do exactly the same thing. I mean, we could even put the Hilla click button and the flow button next to each other, hook them up to the same signal, and if you click one, the other would automatically update. And that's quite cool. Not very useful, but cool. But there's even more exciting things here, because you might not notice this, but when you typically build applications with Flow, you end up doing all the UI state management yourself. And that kind of sucks. Because the way you would have to do it is when I click the button, I would need to find what are all the places, what are all the components that use this number. And I would need, in that click listener, need to update the text in all of them. And that's still doable in a simple case, but as you get more places using the same data, you probably end up building a framework around it yourself. And well, we're the ones that should be building a framework so that you don't have to. And also, when you got more complex logic, it's not just kind of showing this count button, but it's actually kind of, if this piece of state has this value and that thing is that and that is that, then this part of the UI should behave in that way. And then whenever any of those three change, you need to take all the two other values into account to know which is the actual state of that thing. And usually you forget one of those cases. So usually you have it kind of, if I do that first and then that thing is updated. But if I start there and then do that, then we have this bug that then I forgot that one if in that one part, and then you have a bug. Because what happens here is that you just say, this is my UI state, this is what the UI should be based on that state, and then we let the framework take care of updating the UI. I know this is scary because it means you need to give up some control. And as developers, that's always scary. But at the same time, my experience from switching back and forth between Flow and Hilla for the past couple of years is that when I get back to doing something in Flow, this UI state management, it's always the thing that kind of makes me think that, no, wait, maybe I should go back to Hilla again. But at the same time, I'm really kind of enjoying the power of doing everything with just pure Java. So I still stick to it, and I manage to push through and do all the other awesome things. But that's the one thing I would really want to fix, and now finally we see how to do that. So that's the second exciting thing that kind of we're starting a little bit. So we introduced, we call it full stack signals as a preview feature in Hilla, and that's mainly for collaboration. So when you want to share that UI state between different users, push them out over the network and so on, then that's what we're now starting with, and then the plan is to go further and further. So tomorrow I will talk about sharing UI state in general, how to do it today with Flow, how to do it today with Hilla, how to do it in the future with Flow or Hilla with full stack features. So as we see, collaboration, multiplayer, real-time updating, that's really all about UI state management. But the really cool thing is that everything almost is UI state management. So form binding. We got the value in this field is this, the value in that field in that. That's really much UI state. Then we got the validation status. Well, we should compute it based on those things. Whenever any of those values change, that's a UI state update. So more UI state there. And then also based on the validation state, you do things like should the submit button be enabled and so on. So there's even more kind of step by step UI state affecting UI state affecting UI state. And with signals, that's just very, very awesome. Even better, session replication. I actually, in the bar yesterday, I spoke with one Vaadin developer who flew in already yesterday. And he said that could we have it so that we can just really easily save the user's UI state in the afternoon when they stop working, and then the next morning when they come back, can they just continue from that same place? Or maybe they work on their laptop, they need to switch over to jump on a bus or something, switch over to the mobile phone. Could we just kind of move over the UI state to that device instead? And the way it works today with Flow, you need to serialize the whole component tree. That component tree has references to your database and everything, which means that it's a huge thing that you're serializing. And it's doable, but it's a little bit of a mess. If we go to this future of mine with signals for UI state management, you have the code that says, with this UI state values, you go to this rendering, this visual representation of what's actually shown on the screen, which means that we only need to store the values of those signals to be able to move things over between devices or store things to the database and pull them out next morning and so on. And that's also really, really exciting. So I would say everything in front-end development is very, very much about UI state management. And like I said, UI state management, it gets so much nicer when it's a signal. So basically, I hope everything will be a signal. And I see a future where everything is a signal and everything is full stack, and that's how we get to full stack signals. Thank you.